All right, this is the very first lesson in Math 2. This is how things are going to work. I'm going to go through each set of notes and I will introduce a bell work, which you should sit down and do within the first 5 minutes of class. At that time, I'm going to take attendance. I will come around and check all your homework or collect things that I assigned for that previous night, and then we'll go from there, okay? Taking notes as far as things go, I do not require that, but it is strongly advised. There's a strong connection between writing things down and recalling them later, okay? So my encouragement would be to take notes, but you don't have to. You can always go offline. You can print off these copies of notes that are all available on the website here and then bring them to class with you. So if you're that type of person that has a hard time writing things and listening at the same time, then my strong suggestion would be to print these off before you come to class and bring them with you so that you can just write things down on them, okay? So for number one here of the bell work, what is a number, okay? This is a very broad question. Some people are gonna give me answers like 5, okay? 5 is definitely a number. But this is just asking in a general sense, what is a number? Okay, the idea here is that numbers are a very complex situation. People struggle with math because numbers are hard, okay? Take your time, allow yourself to be able to get frustrated, because if you're not frustrated, you're not learning anything. All right, I'm gonna define number on the next page, so I'm gonna go ahead and skip this, but you should have already had some kind of thought process going in your head, okay? Number 2, can a letter represent a number? All right, the short answer to that would be yes. And the reason is, if we have something like a variable, okay, the variable x represents a number. Y is a variable, it represents a number. Okay, we would be able to put that in some kind of expression and or equation and have it represent a number, okay? Number 3, provide an example of a number that is represented by something that is not a number, okay? And then let me go ahead and add to that. Let's do one that's not represented by a number as well as not represented by a letter, okay? I don't want a variable here. So number 3, you would have pi. Okay. You should have filled out your bell worksheet. Bell worksheets will be used before every class. Again, that'll be during the time in which I take attendance, etc. And you should take that form, you should put it away someplace safe, because at the end of the week I will collect those and I will give you a point for each day. Okay. Be sure that you are writing all of the questions. You may paraphrase them and write a shorter version. So something like number 3 there, if you wanted to not write that entire sentence, you could shorthand that. Just make sure that you understand what the question was, because this is our textbook. You don't have a physical copy of a textbook for me to give you, so I'm going to expect you to understand how things flow and where to find things when it comes time to do assessments and things. Okay. So here, as promised, I'm going to define a number. Again, if you look at the board, you should understand that, again, the complexity of this. Numbers are extremely difficult. Okay, when somebody asks for a number, they're not simply looking for the number 2, the number 3, the number 5, the number 600 million. Okay, this is an arithmetical value expressed by a word, symbol, or figure representing a particular quantity and used in counting and making calculations, and for showing order in a series or for identification. Okay, thank you, Webster Dictionary, for making life complicated. Again, the whole idea here is to understand that everybody struggles with math, and there's a reason why. Okay, numbers are very complicated and complex. All right, take your time. Again, allow yourself a little bit of frustration, because if you're frustrated, you're learning. Okay, when you get to the time when you're a little beyond frustrated, push it off to the side. Okay, take a few breathers, do some other homework, play a video game, do something for a little bit, and then come back. Okay, we want you to be able to get frustrated. We don't want you to get extremely aggravated and just shut down. Okay, I do want you to learn and absorb things. Number classifications, otherwise known as number subsets. These are 7 subsets that you're going to be responsible for. You should have, in the past, already discussed some of these. They should look very familiar. Okay, some of them not so much, but others of them should look very familiar. Okay, things like natural numbers. Natural numbers are the counting numbers. Notice they are at the very bottom there. Going up from natural numbers, we have whole numbers. From whole numbers, we go to integers. From integers, we went to irrational and then rational numbers, and then real numbers and complex numbers. Okay, up to this point, I would say the only thing that should be new for sure would be complex and real. The others should have been hit on a little bit. You may have only heard rational maybe once or twice up to this point. Irrational, it kind of varies, it depends. But integers, whole numbers, and natural numbers you should have definitely heard of. Okay, the following pages here, we're going to go ahead and go into great detail and describe what each one of these are. Again, you are going to be responsible for knowing your subsets, all 7 of them. Okay, so breaking down the subsets. Again, I'm going to start from number 1 there, and I'm going to go down to number 7. So number 1 was complex numbers. At this point of this curriculum, every number that we work with right now will be considered a complex number. Okay, this is a number system that is very large and at times very confusing. So in other words, it's complex. Okay, real numbers. Real numbers, again, is something that you probably haven't heard of, but we're going to talk about that here. Every number that we work with at this point, again, will be a real number. So what's going to happen is I'm going to ask you to classify numbers, and I'm going to ask you to do it in 2 parts. Okay, part 1 or part A is going to ask for the best classification, and that's going to be where I would place this number originally. Okay, where did it first come into play in my education? The second thing that I'm going to ask you to do is to list every other subcategory that it falls into. Okay, in part B, complex and real should be 2 words that are appearing every single time. Okay, every number that we work with in this class will fall under the real numbers and complex numbers until we get to Unit 2C, and then we'll break down complex numbers a little bit more. Rational and irrational numbers. Rational numbers, again, these are very complex definitions, so make sure that you are able to distinguish between rational and irrational. They do kind of mean the same thing. Notice the IR on front of the irrational. Those of you that are English people, IR meaning the word not. Okay, so rational and not rational. All right. Rational numbers are any numbers that can be written as a fraction. 1/3, 1/2, etc. Second thing there, this includes decimals that either repeat, okay, so 0.3 repeating, 0.125 repeating, okay, or the decimal itself terminates, okay, in other words, it comes to an end, so 0.125, 0.3, okay, 0.2. All right, so understand that they have to either repeat or terminate, come to an end. Okay, and that's because then those decimals can be created into fractions. The third thing there, this also includes perfect roots. Okay, so you're going to see that little square root symbol, but at times you will see a little index number. That's the little bitty number that's inside the little hook that is on the outside left. Okay, and that tells you what root that I want. So if you just see a square root, it's the square root. If you see a little 3 inside that little hook, then it's the cube root, and then etc. Okay, we'll work with those a little bit throughout this unit. Moving on then to irrational numbers, you'll see a flip of everything I just stated here. So these are numbers that cannot be written as fractions. They are not rational. The decimals do not have a pattern or terminate. You must include both of those things in your definition. Okay, you need to understand that. These are decimals that do not stop or have a pattern. Okay, where rational numbers either stop or they have a pattern, one or the other. This negates both of those. It cannot stop, and it cannot have a pattern. And the bottom thing there, these are non-perfect roots. So something like the square root of 5, the cube root of 9. Okay, those are non-perfect roots. Integers, whole numbers, and natural numbers. The last three of our sets here. Integers are numbers that are positive or negative. And then I put here typically something without a decimal. Okay, so I always ask the question in class, if you can give me a number that is an integer but is a decimal. Okay, and it gets people thinking a lot, because if you think about an integer, if you think back to your earlier days in school, you always have that teacher typically that has that yellow number line that's up above the board, and there's a main focus on that above the board. Okay, it usually goes from like -10 to +10, or from -20 to +20, or something to that effect. Those are integers. Okay, those are numbers that are integers. Again, those are something without a decimal. But if I ask for something that is an integer with a decimal, then I could say what? All right? And you're sitting here probably thinking, oh, I'm not sure. Okay, but if you add a 0.0 to something, does that change anything? Okay, so in this class, I'm going to want you to start thinking again outside the box. I want you to be able to manipulate things and to make things work to your need, because that's what math is about. Okay, it's about taking things and manipulating it around so that you can understand things in your manner, not necessarily how it's typically taught, but how you understand it and comprehend it. Okay, and that you can maintain it. So if you have questions, feel free to always ask me. Okay, I can explain things in a whole lot of different ways, but I can't explain them if I don't get the questions. All right. Think about integers again as a number line. Okay, I've already stated that. The next thing, that whole numbers. These are numbers that describe a quantity of something. Okay, these start with 0. These are only the positive integers. Okay, but they start with 0. And then natural numbers are counting numbers. Okay, counting numbers 1, 2, 3, etc. All right. Think about this. If I go from natural numbers, and I go up the line of what I just went through, those are how they are typically introduced to you throughout your schooling. Natural numbers are where you started from when you were a toddler. Okay, little kid comes up, ooh, mommy, daddy, look, 2. Okay, ooh, 1. They don't understand the concept of 0. If you have 0 of something, that child, that toddler is extremely frustrated and upset, and they're bawling their eyes out because they want it. Okay, counting numbers are again natural numbers. So you start learning that stuff when you're just a little bitty. Okay, whole numbers, then you start to learn that 0 is an option. It is possible that you will get nothing. Okay, and that's okay. Integers, we then start learning back usually sometime around middle school area. Then you start learning the fact that you can then start owing people money. Okay, negative numbers. Right, negatives are fantastic. Rational and irrational typically are not talked about a whole lot until you are in high school, because it's a difficult concept to try to think about a number that does not ever end. Okay, that's mind-blowing. All right, if I started to write a number right now, or if I went back 20 years ago and I started to write a number, and I continued to add a digit or 30 of them each day, as soon as I passed away, that number would then stop. Okay, so no matter how many digits that number would then be, it went from being what was planned to be an irrational number to being a rational number, because it doesn't have a it doesn't continue on. It would just stop. Okay, continuing on. Okay, this graphic organizer is something that you should write down. If you're in class, you have a copy of the worksheet that has this on the back of it, and you should fill this out. Okay, every time I ask about something with number subsets, you should picture this in your head and be able to use this, okay, or be able to recreate it. If you pay attention to it on the left-hand side and then the right-hand side, we have this kind of big box split up into 2 individual boxes. All right, and maybe I should highlight these a little bit, so let me go ahead and help that. So right here, I have this divide. Okay, so I have this box here on the right, and then I have the rest of it there on the left. Okay, so notice that splits it up from irrational and rational. Okay, so notice on the left-hand side, rational numbers includes the bulk of what we are working with. Okay, but if we look at those innermost boxes, the natural numbers fall innermost. Okay, they are inside of the whole numbers because, again, as I mentioned, whole numbers only add the number 0. Then from whole numbers we start to introduce negative numbers, so that's when we go up to integers. And then from integers we start to introduce fractions and square roots and things of that nature. Okay, and decimals. So then we start talking about rational numbers. And then again, those are all blanketed by the real and complex systems. Okay, so again, you're going to be able to remember these if you put this together. Okay, this will be asked for on several things throughout this entire first unit, so make sure that you're able to distinguish between a natural number, a whole number, an integer, a rational or irrational, and then a real or complex number. Okay. This is just a little explanation of how to use the chart. So a number is either rational or irrational at this moment. Okay, again, it's not going to be anything other than that to begin with. You're going to find that innermost category that the number will fit into and then flow outwards. Okay, so if I ask for the number 5, if I asked for your best description, it would first be introduced in the natural numbers. Okay, and then natural numbers is that letter A. That's the best classification. And then letter B of this is going to be, again, explaining which other subsets that it would fall into. So if I start from that middle or that innermost category, again, flowing back to this chart, if I started here, then part B is everything flowing outwards. Okay, it doesn't veer over this way, it just flows from here and it goes out. Okay, so A would be this. If I said 5, A would be natural numbers, B would then be whole, integer, rational, real, and complex. Okay, I don't care what order you place them in, I just care that all of them other categories are there on the paper. Okay. If it starts at whole number, so the only number that should start at whole number, period. So the only single digit that has the word whole for part A would be the number 0. Okay, and then part B, flowing out from whole, would be integer, rational, real, and complex. If a number starts at integers, in other words, I give you a negative number, okay, then that starts at integers. And then flowing outwards for part B, just rational, real, and complex. If I give you a fraction, or a decimal, or a square root, okay, then that number is a rational number and then flows out to real and complex. If I give you a number that's irrational, so such as the number E, okay, yes, I said the number E, not the letter E. E is used in banking quite a bit, okay, for your interest, all right, or for population size. Okay, but again, that's not until further mathematics anyway. But if I give you an irrational number, such as, again, pi or e or anything like that, then that is starting there, and then flowing out again for part B would just be real and complex. Okay, 2 pages of examples here. I've already got these filled out, so again, just make sure you pay attention to them. Please understand that these are not all-inclusive lists. Okay, so I do want you to give me some non-boring numbers. Be creative. Okay, have fun with this. Yes, math is a very difficult and frustrating concept, but if you start to have fun with it and try it, then you can open up your horizons and learn a little bit. Okay, so number 1, identify 3 numbers that are natural numbers. Notice at the very end there, I have the square root of 4. Okay, so you're probably sitting here thinking, well, that's not a natural number. He messed up. No. What I want you to do, at least for the purpose of my class, is I'm never going to put the words simplify on anything. Okay, my thought process with math is that simplify should be an unstated rule. You should always simplify if possible. So if I give you something like the square root of 4, I don't want you to view it as the square root of 4. I want you to view that as 2, because the square root of 4 is 2. Okay? So that's why it's under natural numbers. It's the same as the second number there, number 2. Number 2 there, identify 3 numbers that are whole numbers. Notice again, I had fun with this. I put 0, 1, 2, and then 378,452,612. Okay. Number 3, identify 3 numbers that are integers. So notice here, I have 1, -1, -24, 40, and then I throw in some of those decimals that I talked about, 38.0, 100.00. Okay, doesn't matter how many zeros, as long as it's just zeros at the tail end, it's an integer. Number 4 there, identify 3 numbers that are rational numbers, but are not part of the other categories above. So here I'm looking for simply fractions and or decimals. Okay, so 1/2, 1.25, negative 3.125. And then this is the last page here, number 5, identify 3 numbers that are irrational. So here, the number pi, the number e, okay, the number square root of 5. There is a square root of 5. I'll find myself in class asking a lot of times, is there a square root of 5? And people will say, no. Well, in fact, there is a square root of 5. It's just not a nice integer. It's not a perfect square. Okay, so square root of 5 is a decimal that doesn't stop, doesn't repeat. And the square root of pi. Okay, again, these are not all-inclusive lists, so understand that there's way more to list than what I have here. Number 6 there, how many of the numbers mentioned in the first 5 examples are real numbers and complex numbers? You'll notice there the R with the 2 legs on the left-hand side. That's a shorthand version of writing the word real when you're referring to real numbers. Okay, that's the real number set. All of them. Okay, again, as I mentioned at the beginning of this, all numbers that we worked with at this point, okay, and this is till the end of the first semester's material, all of them will be part of the real numbers and the complex number system. Okay. If at all, at any point in time throughout this unit, throughout this year, throughout any time after you've had me as a teacher, that you have any questions, comments, or concerns, feel free to reach out to me. Send me an email, message me on Remind if we still have Remind, okay, or however you need to get a hold of me, okay. Come back to my classroom and ask me a question. You're never bothering me, just ask questions, okay. Again, math is a very hard and complicated topic for most people, okay. The only way you're going to be able to succeed is if you ask questions and you get it broken down to you how you need it to be, okay. That's called being an advocate for yourself. You'll hear me say that throughout this unit or this entire year, but you have to continue to advocate for yourself. If you have questions, comments, or concerns, let me know and I will answer them for you, okay.